Hi, this is Chris Colo. I'm with the VRARA Association. Today we're presenting to you our online symposium, VR and AR in Healthcare, presented by our Healthcare Industry Committee, which is comprised of doctors, specialists, and startups in the healthcare vertical. Thank you so much to our sponsors, which include Medical Realities, Alma Gated Vision, Pico, Icona, and Dr. Matthew Prekupek. Next slide. So a little bit about the VRAR Association. We are the Global Association for VR and AR, association formed in 2015 with the mission to accelerate the market for VR and AR. We have over 3,900 companies registered with us, and we have over 20 committees. One of them is this healthcare committee. We have 40 chapters around the globe. Please look on our website to see if your city has a chapter. We have training on site and online. We provide equipment. We have a lot of research and do a lot of events. Please join us at VRARA.com. As I mentioned, there's many different industry committees, so you can get involved whatever your vertical of interest is. And again, today we're presenting the healthcare committee, which is comprised of the doctors and institutions and startups that you see on your screen. With that, I'll give it over to one of the co-chairs. Brendan, it's all yours.
Hello, this is Brandon, Dr. Brandon Burkhead. I'm the co-chair of the committee and also resident physician in radiation oncology. And today I'm going to talk, some of my talk will be on the challenges in therapeutic VR research. So just to give an outline, talk a little bit about myself, a little bit more about what the committee has been doing since January, and then a little bit about a research group that the other co-chair, Brendan Spiegel, and I have been fostering, and then some of the interesting discussions that come out of that. And so the committee was founded in January 2017, so beginning of this year, and we've had some great conversations and projects that we've been doing since then. What I've been doing in my own time has been several different studies, or started a few different studies. One has been at Mayo Clinic with a group of medical students where we've opened up a study at Rochester and also in Phoenix to assess the ability of mobile VR, specifically Google Cardboard, to attenuate pain using the cold pressure test or an ice bucket. And the other studies, we've been helping medical students as well at Medical College of Wisconsin in Milwaukee, and we have one, probably the one that's going to be completed next will be one on physician empathy using 360-degree videos of patient experiences and kind of seeing the burden of what they're going through and how that might affect physicians' level of empathy. And then there's also, I'll have a review paper that I reviewed with some colleagues at Moffitt Cancer Center. We looked at the research that's been done in surgery, actually, with virtual reality to improve medical education for medical students. And then we're applying that to what can be done with radiation oncology residents. And so, and the last thing that I've been kind of working on, that was the first thing I worked on probably 2 years ago, was how to get VR into head-restricted practice. So radiation oncology, all the patients have to lay flat, can't move a whole lot, and also dentistry, which has a lot of anxiety, can't move a whole lot. So that was another area that I had the pleasure of kind of working in and experimenting in, and I definitely have to say it's been quite a ride. So what's the committee been up to? The committee started off with, we did a survey and we looked at challenges facing the VR startup community, mainly because we look at the VRARA, it's probably one of the largest directories of startups in the VR space and industry. So I assumed that probably with all of us connected, we're probably 1 to 2 degrees away from majority of people in the space. So I thought it would be a good avenue to find out what are the challenges they face. We've also had some speaking opportunities such as this. In the past, we've done webinars, and several of the members go to conferences quite often engage with others. We've also looked at looking at specific topics. So one topic I wanted to discuss with the committee was medical education and the use of, again, 360-degree video and full VR, computer-generated VR, and its uses in team-based learning. And I've also shared that idea with some colleagues at Mayo Clinic, and we may see that specific project may be something that might be done in the future, in a future pilot study. And then, of course, the self-care symposium is something we're quite proud of. So the survey was something we looked at, and again, here you can see some of the results in more detail on the website. I'll have to say, most of these challenges are challenges that researchers face as well. I would say funding and clinical organizational challenges are apparent, pretty much whoever's working in healthcare. And then, of course, all the others as well. So then, kind of branching off from this, Dr. Brendan Spiegel, when he joined the committee, had a fantastic idea to create a group of researchers and get a discussion going with them to see about some of the challenges and also having a framework for doing research in VR and how that would look like. And so I searched for members for that group, created a platform that we could communicate with, had created discussions and questionnaires that reviewed with Brendan and his team at Cedars-Sinai, and so from that we're really hoping to kind of create a best practice model, if you will, for research, and then also some of these challenges, which some of them are been quite enlightening. So to start with these challenges, I'm just going to talk about a few of them today because I'm wanting to just kind of give a quick intro, and I'll probably write this up at a later time. One of the challenges that really came to the idea of doing this was the quality of literature that's out there. You know, this is still a pretty new field. It's been going on since the early 90s, but as far as the volume in comparison to other medical literature, it's not, you know, hasn't had a lot of studies done. And one of the issues is that all the studies are done differently to some degree in their quality and their design. So it's hard to make a real good comparison or a meta-analysis to really kind of tease out a good, is this working, you know, and to what degree is it working? And so that's what the VR group got together to discuss. And then also Brendan and I are working on a manuscript that hopefully we'll have be able to share the details of with everyone at a conference that, again, Dr. Brendan Spiegel is going to be running. I'm sure he'll be talking about soon, a conference in March 29th, 28th and 29th, and so you'll hear more about that soon. So another challenge that comes up quite frequently, it's not actually probably on the top of my list, but I would say frequency, it comes up probably the most, is the challenge of terminology. I think it's interesting. You know, a lot of people talk about the spectrum of VR to AR. Google will use those terms almost exclusively. Mixed reality is more kind of talking about the whole spectrum, if you will, virtual to augmented and everything in between. Microsoft will use that term for their product specifically. And then XR, extended reality, is just another term. I would put it as a synonym of mixed reality. And again, Qualcomm somewhat branding that. The challenge for researchers is sometimes what's been said in the 1990s is not what we would call VR today. So the terminology is evolving at a rate that is hard to keep up with the technology's rate of evolution. And so with that, this is a bit of my own personal, I don't think I have a solution for this really, other than I like to make sure when I'm stating something in a text or in a document, that I always try to use at least once to make people not get too much confusion, base a term based off the function or the purpose of it. So I like to say immersive technology, and we're all working in immersive technology because that's the goal. I honestly don't know in 2050 what people are going to be using or how many photons in their field of view are actually going to be generated versus real. But what I do know is everyone will be using it to immerse themselves, or to enhance whatever they're doing, because that's kind of what people have been chasing since Skip and Walter and several of the founding researchers have been doing since the early 90s and even 80s. So I leave one citation down here for everyone. This is Milgram. He has a fantastic paper on defining kind of the technology within this and giving a spectrum of immersion. I just really found that paper to be quite good. Another challenge that was brought up by researchers is the challenge of if when researchers make a program, is it good enough for what is the quality that we see in industry? And I don't know if this is actually a challenge per se. It's a challenge, a fear of researchers more than probably a real challenge, because the interesting thing is you see Snow World down here with the snowmen showed benefit in 2001, 2002. And then you see over here, Robocall, I forgot actually the name of its title, but it's a fantastic title in Oculus. But you know, there's a difference in graphics, but that doesn't mean that the resolution necessarily stops our ability to get clinical impact. It may in certain populations that have a lot of VR experience, but I think time will tell whether this really has a huge impact or not on our ability to do research. It may make some difficulties that we can improve with collaboration, which I think will happen in the future. We'll collaborate more with academia and industry. And then one thing I'll probably just leave with this point is the cost of research is an issue. It's an issue on multiple levels. It's probably our biggest issue. You know, there have been single institutions that have done randomized controlled trials, and it's fantastic that that has been done. But at some point, as this industry grows and as more people are interested in finding out what this really is doing in healthcare, we may do multi-center randomized controlled trials, but those cost significant money that is out there for pharmaceuticals and technology and NIH. But I hope that the government will have more grant funding, but this might be one particular issue that the industry may at some point need to consider research grant formation or philanthropic funding, even the ability for CROs, which is contract research organizations, to tailor research for VR or the development of research studies and services. So all of this is a bit in the future, but nonetheless, I think that one is for sure a real challenge. So with that, I just want to say thank you for my portion, and you can reach out to me. I'm fairly active on Twitter, and then also through the VRARA.
So I'm showing you a picture now of one of our hospital rooms, and we have almost 950 of these in our hospital. It's a very large hospital, and we were one of the first hospitals in the country to have private rooms. But, you know, make no mistake about it, this is not a place of healing. It's not a place of rest. Being in the hospital is very difficult. Our patients suffer physically, emotionally, socially. So we thought this is not, you know, a place where people want to come. Is there an opportunity for us to improve the experience of our patients? So we started in the hospital. I took a picture of what it looks like from a patient's point of view in the hospital room, and they're looking at that television screen and they're looking at the ceiling, and every so often somebody like me comes by and looks at the patient, not necessarily smiling, not necessarily engaging in a helpful way, and we disappear and come back again, and all day long this is what patients experience. So early on, this is now about 3 years ago, we thought, what if we were to use virtual reality to transport our patients beyond the four walls of this biopsychosocial jail cell? What if we can bring them to a beach, or we could bring them to the stage of a Cirque du Soleil performance, or in a helicopter over Iceland, and see what would happen to their pain, to their anxiety, to their need for opioids or narcotics, to their length of stay in the hospital, or even their satisfaction with the hospital stay. And what's happened since then has been pretty remarkable in terms of what we've seen. And this is a picture of one of our patients using virtual reality for the first time. This particular young man has sickle cell disease and has been suffering from severe pain crises related to sickle cell anemia. And at this particular moment, he's on in VR.
And there was a question on how open have you found the medical community using VR, AR to treat patients or for training? I would say it depends on the institution that you're at. So it's all that introductory conversation of how comfortable do they feel. If you go through the proper channels, like research and IRBs and you show a result, then they probably get more open. Or if you do a lecture kind of showing the different amount of evidence, they're pretty open to it. You know, definitely just right off the bat, some people might say, oh, is this just for toys or for video games? And you do kind of have to break through that barrier sometimes, but, you know, just depends. Yeah. Have you used VR in the primary care setting? Others have looked at it in the primary care setting, such as, you think of some people in primary care. Yeah, I don't know of any. I would say primarily it's been psychology and psychiatry, but I do know some internists at MCW that I am talking to try to see if they're interested in using it there. These studies have been done on homebound patients. That's a good question. I think there has. I think there's been studies done, but I don't know. So that would be like telemedicine type studies, and there is a lot of interest in that, particularly with the HoloLens, just because it has so much information it can get from tracking. And so there are studies. I can't think of any right off the top of my head. How it works?
Yeah, read the question out loud.
Yeah, so where can I obtain the necessary research you just spoke of? So I like to tell people to search for PubMed.com. So PubMed is a fantastic search engine, and you can essentially look up whatever you're interested in and then look for add review, and you get great review papers that have been done in VR for most of the prominent areas, so pain relief, PTSD, several other prominent areas. And so I definitely highly recommend it. And do you alter the VR experience based upon the patient population? Where are your go-to experiences? Do you alter this by age? Absolutely. Nothing should be made just generically for different patient populations, different diseases. Absolutely, it should be tailored. Go-to experiences. There are probably a few go-to experiences that have been studied for pain during perioperative procedures, like Snow World. There's kind of this calming shooter genre, if you will, but that will probably differentiate over time, and it should be altered by age just because there's anatomy differences, there's visual acuity differences, so you have to kind of judge what headset you're using. Are there any studies happening in Chicago area? Well, I'm doing studies in Milwaukee, but absolutely there should be some work in Chicago. I know the CEO of Cubicle Ninja, he does guided meditation. He's trying to get some of his work into some of the universities.
Oh, yours.
Okay, great. Well, thank you for having me here. It's really a pleasure. And I am a general surgeon. That's my main focus. That's my full-time job. I'm a general surgeon with a very strong interest in using technology in a smart way in order to improve what we do as healthcare providers and also as educators. Not just educators of future providers or of colleagues, but educators especially of patients. I really believe that we have a very fundamental responsibility in trying to get patients to understand what we are trying to tell them about their problems, about their pathology, about the treatment and the potential preventive maneuvers for them to stay healthy and to be healthier. Really, my mantra is almost that the smart application of technology in order to revolutionize how we do healthcare and how we teach it. Okay. I've always been interested in gadgets and technology. I'm somewhat of a geek surgeon, I guess, and I'm very excited about the exponential development of technologies. I think that this exponential curve really has no limit, and using that technology in a smart way will really radically change how we do healthcare. And I don't think we can even imagine. We cannot even dream of where we are going to get. Next slide, please. So exponential medicine is part of a Singularity University. Singularity University is an amazing concept that became part of Singularity University through their Future Med program, which is what exponential medicine used to be called. It was a short program of about 7 to 8 days, and about 80 of us were really exposed to incredible technologies down in the heart of Silicon Valley at the NASA research facility. One of the amazing things that I saw there was the Google Glass. When I saw Babak Parviz, the inventor, one of the inventors of Google Glass, demonstrate what this smart glass could do, I was immediately wowed by its potential in healthcare and in education. Next slide, please. So I basically thought, wow, I really want to first get one of these Google Glasses, and then try to use it in how we teach students, how to stream the surgeries, the content of what we do to an audience. So I got one of those glasses as one of the early Google Glass Explorers, and did an operation for the first time ever, an operation using Google Glass in a live form, streaming the content of what I was doing to a direct group of students situated remotely, rather than crouching behind my back trying to see my perspective. And we can go to the next slide. Then I was showing them the focal point, and hopefully this video plays. The focal point of my perspective. So they were virtually with me in the operating room. They were there basically asking questions, answering questions, and just really there with me without having to be there with me. They were in the next conference room sipping coffee while they were in first seat level for the surgery. Next screen. So obviously that really, in a way, caught a lot of attention. It had never been done before, and that got me to become sort of an influencer, of an advisor, of a consultant, of a speaker. I ended up doing 4 TEDx talks over the next couple of years on the use of smart glass head-mounted technology to improve healthcare. So lately, I've been focusing a little bit more on what I call mixed reality or immersive reality, as Brandon was mentioning. It's really a combination of virtual, augmented reality to what we call spatial computing now, which is mixed reality. Next slide, please. So a mixed reality, as you probably all know, it's really a revolution in how we are doing computing, how we are connecting to the digital world. There are many companies, tens and tens of companies out there that are betting on this, because this is a multi-billion-dollar industry already, and it's going to be much more in the next few years. Next slide, please. The iconic device, prior slide. The iconic device for this, we can go to the next slide, please, is a Microsoft HoloLens. The HoloLens, when I tried it a couple years ago, very, very early on, completely amazed me. It's a computer in front of your eyes, and you are computing not on a screen. You are computing and working on a virtual holographic desktop screen. And you can see holograms in the space. You can go to one room and open the screen. You can go to the next room and open the screen, and the screen will be there until you get back to them. So I thought of the potential of this to be applied to medicine, to be applied to let's say rounding and opening EMR, electronic medical record screens, in every patient room, for example, by wearing one of these devices. And it really got me excited and got me thinking. Next slide, please. So by using for the ones of you who don't know HoloLens, this is a kind of commercial video, but it tells you what it is. The actual glass in front of your face is transparent. You can see through it. It's a pretty complicated set of hardware that is really in a way magic. It's something that is very hard to understand, until you really try it and you really get you can't believe what's in front of your eyes. And this is obviously the first version; is not perfect. But in any case, I started connecting with different people, different startups, different incredible companies, and it was all about how do we see in medicine. And I was thinking of images, of radiologic images, and it's all in a 2D screen. It's in a flat, hard screen. Even if we are looking at 3D images and we can rotate them, it's always in a 3D screen. So it's very hard to understand complex anatomy. Go back to the prior slide, please. To understand complex anatomy when we are trying to see anatomic or pathologic features. It's really, in a way, becoming a handicap for us surgeons when we plan an operation and when we operate. It's also impeding how students learn. It's impeding how patients understand what we're going to do. And it's really, really hurting how we connect and how we communicate with patients and with colleagues. I always say, one of the causes of errors in medicine, and errors kill 440,000 people a year, preventable medical errors. And I think that one of the root causes of this is the lack and the difficult to communicate and to connect. Next slide, please. So it got me thinking and looking at how this has evolved over the years. It's really amazing that we have technologies now that it could make this process a much better process. Next slide, please. It's really revolutionizing the way that we use hardware technology in order to improve how we do and how we teach healthcare, from a platform that is a mobile platform that's called Anatomy X to the Render X platform, which is a HoloLens, a holographic based platform. Next slide, please. So Medivis is really revolutionizing what we do, how we do plan an operation, how do we teach an operation, how do we teach the basics to do an operation, and even how we do the operation itself. And I hope the videos play right, and they don't have an audio. It doesn't matter. It's the visuals. You can see the rendering of what the HoloLens Wear view is, and you are immersed in this hologram, which is an anatomically correct visualization of, in this case, just plain anatomy, to learn anatomy. But not only that, you can bring that to the operating room, and let's say a patient is being operated, and you can bring their actual anatomic radiologic studies to the OR, and you can plan an operation, and then during the operation you can access these images in a way that we were never able to do before. We could never play and look at the images in such a dynamic and immersive way, but you can superimpose the holographic, accurate, radiologically correct image on a patient that you're about to operate, and then in a way guide your operation in a way that we could never do before. What impressed me is the dynamic aspect of the interaction between the viewer and the actual image. And obviously, this is in a way a proof of concept for utilizing this software in an actual procedure. But you can easily imagine how something like this can jump a very short gap or leap in order to become a reality, and how using the appropriate technology you can in a way guide your surgery to be more accurate and to be more precise and to be certainly more visual. Quest, it's a learning tool about cardiac physiology and pathophysiology, and you have the heart floating in front of you, and you can interact with the heart in a way that normally you couldn't before. We started being able to open the heart and see the inside anatomy. It's all anatomically correct, and it teaches you about our normal heart, about different conditions like a heart attack or hypertension or dysrhythmia, atrial fibrillation. And then we kept going and going and trying to then play with this interaction more and more, and then created what we call, or I call, a hacking mixed reality. And maybe we can go to the next slide. While all this was happening, then we said, well, ARKit is coming, the new Apple platform, as sort of as AR Core is coming for Google, and then we said, this is phenomenal. You don't need a $3,500 viewer. You can do it all on your phone, on your smartphone. Next slide, please. And then they created this ARKit platform that is available in the App Store with any smartphone 6S or above or newer, and then you can interact with the heart in a way that is almost hard to believe. The features now include opening the heart, like I said. All the structures are labeled or not. Some of these features also, so the Apple Watch will basically link you to the app, and then you can visualize your own heart rate. You can visualize your own heart rate beating regularly or irregularly. So for me to teach a patient, a little old lady, a little old guy who has atrial fibrillation, and not just tell them, but show them how their own heart rate beats on a three-dimensional heart, a hologram floating in front of them, is just really priceless. I believe in the power of the technology being used in a smart way in order to improve how we do teach healthcare to patients and to future providers, and also how to actually do healthcare.
As this technology gets wider and it's this distribution curve, do you see it as a daily tool in patient education, pre and post surgery?
Absolutely. I think I really, truly, completely convinced that the way we display information to patients in any industry, but in medicine, it would be using this very, very common, they're going to be very, very common tools to explain things in ways that we could never explain before, and I think people will understand in ways that they never understood before. So I'm completely convinced of that, at every level, from the basic level to the marketing level to the very, very deep medical knowledge level, to when you're trying to learn this as a provider or as a medical student.
Another question is, could you comment on what it is like to wear HoloLens in surgery? How heavy is it? Does it increase operator fatigue? What is the battery like?
The HoloLens, it's a first edition type unit. It is somewhat heavy, but it's very, very well ergonomically designed. And I've worn HoloLens for a long, long time. Let me clarify that we do not, and no one does, wear HoloLens during surgery. It's a proof of concept cases. You try to sort of in a way, quote unquote, play with the idea of using HoloLens during live surgery. I don't think anyone has done any live surgery using HoloLens. You go through the screen and you have a large sort of set of glasses, of goggles. It's a screen that is almost like my protective screens that I use for when I do trauma or when I operate, but it's really something that at this point is, I couldn't give you a real answer in regards to how it is during a 3, 4, 5, 6 hour surgery. The battery, it's pretty good. I think that obviously the more content you're displaying, the faster the battery gets drained. I would say for a few hours, the battery lasts a few hours. The beauty of HoloLens in a way is that you don't have to touch anything. Everything happens by you manipulating the space with gestures. So that's a very, very important feature. And not only, displaying a desktop in the space, multiple, let's say, images from the electronic medical record, you can bring even content to you. I've been connected with a company called Aethos, and Shafi is going to talk about that, and you can bring a rendering of the indirect virtual avatar to the room with you in a way connecting to people in ways that we could never connect before. A very, very important power in teleconsulting, in telementoring. And I know Shafi is going to show his marvelous videos out there, but yeah, that's the HoloLens. I would say that that is something that obviously will get better. Will get like any technology, faster, better, cheaper, cuter, and sleeker.
Have you experienced any vision issues?
No, absolutely not. I don't wear glasses. I do not know why. I've heard reports of people, not so much with HoloLens. When you go in virtual reality settings, sort of like Oculus, like the Vive, like Samsung VR. Some people talk about that. It depends on the technology you're using. The newer systems are much better. The delay in the image sometimes people complain of vertigo. I have not at all have had any symptoms in regards to my vision. And I am in the HoloLens quite a bit.
Okay, well, last question for you.
Yep.
Related to the point of not using devices in live surgery, do you expect the FDA involvement in certifying HoloLens and other devices?
Well, I don't think that a HoloLens or any other smart glasses or head-mounted computers, be it AR or mixed reality device, or Oculus or Google Glass or HoloLens or the newer devices, is not a medical device. So the FDA has no really a part on this. What is important and what pertains to at least in the U.S. to these devices is obviously the privacy of patient information, and all these devices and all the networks that you're using have to be HIPAA compliant. HIPAA, as you know, is the privacy sort of regulation, the federal private regulation, and HIPAA is one thing that is a must, obviously, but you do not need FDA for any either hardware or software related to these devices, at least until you start using these devices in a therapeutic way. Then it would be a different story. But I think that the FDA is certainly evolving at a good pace, not an exponential pace as we would want, but in a good way. And I've met with many FDA regulators last year or so. I was actually, along with Shafi, through Deloitte, they organized a digital healthcare summit of sorts, and we had a whole number of FDA officials that were very young and very eager to learn and to explore and to really gain understanding of this exponential technology so that they could regulate better. And that was an incredible feat. I, in fact, connected with Shafi by virtual ways. He was connecting through one of the mobile sort of quote-unquote robotic units, and he was in London, and he had a little teleconference with us and showed the technology to a bunch of amazed FDA officers. So that was pretty interesting, if Shafi remembers that. I do.
So thank you, Rafael. If you have time, please stick around. Next presenter is Shafi Ahmed from Medical Realities, which is one of the sponsors of this symposium. Medical Realities has a platform that delivers high-quality surgical training using VR. Shafi, over to you.
Hey, thanks. Can you all hear me? Is it all clear?
Yes.
Lovely. Well, Chris, thanks very much for asking me to speak, and Brandon, great to spend time online, I guess, listening to you guys, and great to follow Rafael. He's a great friend. I really enjoyed his talk. I missed the beginning, but I think we'll just take things further with his talk in terms of VR and AR sort of interface. So I'm a surgeon and mechanics specialist in London. I've been playing around with AR and VR, I guess global surgical training to be my main interest and passion, and how we can use or leverage these kind of technologies to make healthcare more equitable. And that's kind of what I've been talking about in this presentation. So hopefully these slides will work. Let's see, we go. Well, yeah, good. So if we go back, and I talk about this whole thing about the doctor-patient relationship. So think about 2,000-3,000 years ago, in the time of the Greeks, and we all read the Hippocratic Oath when we qualified. This is a pledge essentially to say that we look after our patients professionally and do no harm. But actually, it doesn't mostly about technology and how that's going to change things in the future. And my view is the whole doctor-patient relationship, or the doctor-doctor-patient relationship, is going to change. It's going to evolve. We're already using smartphones, we're using telemedicine, we're using Skype, telephone consultations, and now it's going to be a whole feature of AR and VR in terms of so managing our patients in a different way. And perhaps the whole aspect of hand-holding and touch and feel is going to change. I am a cancer specialist, I break bad news every day. And maybe I'm thinking, actually, how do we redesign healthcare around the globe, given the fact that we have increased demands, less capacity, no money? How do we make things different? And that's the kind of thing I think tech will allow us to do. My own specialist surgery, about 2 years ago, produced a commission by the Lancet, suggesting that 2/3 of the population do not have access to safe and affordable surgery. And that's the sad indictment for mankind, where 2/3 of the population cannot access emergency operations, elective operations, to save their lives and improve their quality of life. And to overcome that, we've trained 2 million more surgeons, and we need to perform about 150 million operations per year to make healthcare more equitable. So my question is, how do we solve some of these issues using technology? So further to Raphael's discussion around perhaps Google Glass, about 2 years ago, I used the Google Glass for live stream around the world. And essentially, we configured the Google Glass so we could stream it live to students and trainees. They could watch on their smartphones, on their iPads, etc. They could ask questions and text them on the mobile phone, which would come up the glass at the same time. So I could teach on a higher level, scaling up education. On that day, actually, we taught about 14,000 people in 118 countries in the same sitting, just showing that we can share our knowledge, not just to 1 or 2 people, but to thousands of people across the world. And that's the kind of thing we've got to do to scale up education, to make it free and accessible. And we used that with Google Glass 2 years ago, following on from Raphael's work initially. We produced some software that you can use to teach and train, and I've been working with various companies to develop the Google Glass and the technology around it so that we can teach on a remote level. I was even lucky enough to teach this man, and Raphael remembers this picture from Dubai. This is John Scully, with a mobile phone company now, and I was actually his CEO of Apple in the past, and I actually taught him remotely how to do a simple operation, just showing sort of how connected people can be with these kind of technologies. The other thing I talked about is social media, and I do a lot of work on social media, as does Raphael. I use social media in a way to teach people around the globe because they're powerful mediums. And we talk about AR and VR. Remember, Snapchat, until just recently, is still the most powerful augmented reality platform there is. It's free. It's available. It has 175 million users around the world. Facebook also into AR now. Instagram also. Facebook has 3 billion users, 2 billion users. So these are platforms that connect people in every part of the globe. But I thought, can I teach using these kind of technologies? Can I teach surgery? So, let me go forward one slide. So I've used Facebook already to teach on Facebook Live, 10,000 surgeons in Bangladesh. I've used Twitter to live stream an operation on Twitter, the first one in the world. And I used Snapchat about a year ago to experiment whether we could teach people on a social media platform. I did 10-second clips of an operation. I redesigned the operation so that we could think about how we teach people in small clips, my story, people could interact, etc. And actually, it sort of made headline news around the world. Time magazine covered the story. And actually, it's quite disruptive. We're using technology in a different way, teach students and trainees using social media. My kids think I'm quite cool because Ashton Kutcher put my story on his wall. And actually, the relevance of this is that it had 2 million views across the globe. It had 100,000 downloads. And every time I operate now on Snapchat, I have 5,000 students across the globe tuning in live, watching in real time almost, me operating and learning and teaching them with text messages, etc., and with AR in the background. And so one thing I must share with you is that recently we sort of had this girl from, I asked the students where you're watching it from, where you've been learning it from. And one of the girls called Ella said, "Hi, I'm Ella, I'm from the Marianas Islands, which is based in somewhere in the Pacific Ocean." So I looked it up on Google. There's just a big blue sea. You keep going and zooming in. Finally, I found a small island, 12,500 people, and she was a student. And I was teaching her literally on a small island in the Pacific Ocean. And that was so powerful. When we looked at this whole thing here about the impact of that operation, in fact, it reached 56 million people in the space of a month around Twitter and social media. Huge impact from simple operation that can be shared by all. So that was interesting. And then this is the picture of the Marianas Islands. This is where it is, middle of the Pacific Ocean, and it's great to connect with people around the globe. The other thing about my work is around VR, and I've been working on VR for a few years. Our company, Medical Realities, is doing VR work, and we are the first company to release an online surgical training module based on VR that's validated. And I think these kind of technologies empower people. I do work globally. Rafa will tell you, I spend time in Gaza, in Africa, in Asia, with my work in the international program, thinking how do we make healthcare more equitable, how do we train surgeons on a remote scale. But I think these kind of technologies break down barriers. They break down the kind of geopolitical borders that we've put up for ourselves for no reason. I think about refugees, Syria, Iraq, all these kind of places, in some ways, could be empowered by AR and VR, and that's kind of my message. So last year, I did the world's first VR operation. We got a bunch of cameras, GoPro rigs. We went live in 360, and I opened up my hospital to the world. I persuaded our hospital to part with some cash, to buy everybody in the hospital a Google Cardboard, to become part of this innovation, to take people together with you. And actually, on that day, we did a live stream of a cancer surgery, and it was watched by 55,000 people in 142 countries. It had 5 million tweets in the 24 hours after the operation, and actually it sort of reached a lot of people. It had 200,000 downloads on YouTube within a couple of days. It just showed you suddenly people want to be taught differently. AR and VR have huge pulling power. We're going to use that going forward. These are my kind of team, 20 developers working on AR and VR, based out at Soho in central London. Quite a nice crowd. And we created the first platform which you all download on iOS, Android, Gear VR, the Oculus, and the Google Daydream. It's available across all platforms. It's important to be universal, device agnostic, to do these kind of cases. And the next thing is, for me, is that how do we make CGI more realistic? We've got to be photoreal. This is my, I guess, selfie, you'd call it. It's me creating my own avatar in using 104 cameras by a process called photogrammetry. And indeed, I became the world's first virtual surgeon, and that's me, virtually. Not nice to look at, but hey, that's the kind of the thing you get out of it. So that's volumetric, it's 3D. We put that into the real space in VR. Suddenly, we create real images. They're going to be photoreal and not the CGI stuff we see in the moment, which are really quite cartoonish. And we've got to move away from that. Add AI interface, add knowledge base. This suddenly becomes a learning platform that's for the future. And actually, what I'll show you next is what we did recently. If I can share my screen, some of you may have seen the work I did about 2 weeks ago, where I shared during the live operation, I used the HoloLens to connect with a surgeon in India, one in London, and the sort of makers in Atlanta, 3 continents, 4 people, 3 time zones to do a live, nonetheless. So what we did essentially use the HoloLens. Imagine this, you're sort of connecting different surgeons using holograms, avatars, real-time, 3 continents. It was a way of showing that we can now do shared learning. We can have an MDT, a multidisciplinary meeting across continents. And actually, the whole interface of human dynamics, and the picture shows at the beginning about the human, the patient-doctor relationship or the human touch, can be changed with haptic feedback, with these kind of things in the future going forward. And, you know, we're working on lots of kind of devices now to bring that forward. And if you want to hear more of my work, you're welcome to see some of my talks that are online. So I'm happy to take some questions.
Yes, the question is, does medical healthcare need full body tracking technology? And if tracking is required, where is it required exactly?
Yeah, really good question. So this is an interesting question. At what point do you need to see the full body? Where do you need to see movement? And if you think about where we are as humans, and in that example I sort of showed you that you didn't quite see, having someone in front of you move around, move their head, nod, actually made an impact in terms of that relationship. So movement is actually quite necessary. Otherwise, you'd be like a still Skype shot where you're not moving through the interface. And it adds, the more realism we add, the more movement we add, the better it is in terms of relationship. But the question is how much do we actually need for that? I mean, people speak on telephone now for conversations. But ideally, it's the upper half, the torso moving, and the head movement is important. And I did an MDT just with a telepresence system, the Beam system, by Suitable Tech. And actually, the fact that you can move it on a joystick, turn around, speak to people. The meeting became quite normalized in a couple of minutes. They felt you were part of the team just because you're able to move and show direction, etc. So how much you need is different for different disciplines. Of course, when you're breaking bad news to cancer patients, you need to be there in real time. There's the hand-holding, there's the human touch, and the whole psychological reason for being there. But we can disrupt a lot more of it, make it more efficient. There's no question about that. Yeah.
Do you think there is a place for HoloLens in the clinical space? What actual use does it serve at this time than neat pictures? Is there any value added by having it in the surgical suite? Doesn't it take up time from your nurses? Do you use an extra circulator when using this tech?
No, I don't think so. I think it'll become. I think it can become very commonplace. But remember, there's two aspects. One is about surgical planning and overlaying images. So, for example, if you're doing orthopedic surgery or neurosurgery or something, now you have a way of overlaying information, scans or images to help you do the operation in real time. I can see a real value in that. There's no question. Also, if you're trying to bring information in quickly from the electronic patient record, for example, in real time, again, that's going to be the kind of thing that's going to, A, make it faster. At the moment, if you ask for a scan or what the results show, someone has to go to the computer, log on, go into the EPR system, which is really slow in our hospitals, find the images, again, that's slow, then you've got to go and want to look at it. Actually, that adds time. If you can do it in real time very quickly, it's all connected. I think it improves the efficiency of surgery, actually.
Great. And a similar question for you, Shafi. Do you visualize any need for regulations in the healthcare system for the utilization of VR/AR? If yes, when to start? When is a good time to start it?
That's a good question. So, thankfully, we're a bit more lucky, Chris, in the UK than America. They're a bit more lenient in what we do in terms of innovation. Only because, for example, the things I've done in the last few years with live streaming things, as long as we get patient consent and we go through the right process of governance and the rest of it, these kind of things were manageable. And I guess other countries, I mean, the US, for example, with HIPAA compliance and things, makes it more difficult. I think there has to be, I guess, when it comes to therapeutic intervention, there might be a need for some regulations. I think when you're teaching and training, I think it's validation of the training itself that is good enough compared to previous traditional methods of training. That's what we've got to prove. So I think it all comes down to it becoming involved in patient therapeutics, so it should be a benefit. Then there might be some regulations about how long do you have the headset on, how long do you keep it, what's repetitive strain like, all the usual things that we've come across in the last couple of years. Yeah.
Next question for you, Shafi. Has the NHS supported your medical realities company, or is this something that you have set up independently? Just wondering what challenges you have faced, if any, setting up a VR health company in the UK.
Okay, so it's a private company, but I have a strong association with all the right partners. So, for example, our own trust, which is the largest trust in the UK, Bart Self, is a partner. The Royal College of Surgeons of England is a partner, and we're trying to validate the work so that we go through the right channels, we approach the right bodies to make sure it's validated, and that we are careful around the legal framework of this all. So we have about, 10 or 12 hospitals now in the UK who are partners. We're sharing our work, want to share the knowledge, and we create a network and a contract with those companies, with those hospitals. So although it's a private company, it's interlinked with the NHS. The NHS is becoming easier, I say easier, less hard, I should say, about influencing innovation in healthcare. We have multiple levels now of digital academies, national centres of innovation, for example, remuneration by tariff of innovation now using apps and things. So we're slowly becoming accustomed to a top-down approach of influence innovation. We also have a national sort of entrepreneurship program where we have 200 or 300 doctors now who are actually allocated a role as entrepreneurs to create the new healthcare system. In my own work, I'm actually in my medical school, we're the first one in the world to integrate innovation entrepreneurship into the curriculum for everybody. So we are making changes slowly to influence healthcare in the NHS.
I guess just summarize maybe or remind us what uses of AR do you envision for patients?
Okay, so let's from the top. From the patient's perspective, one is that education. So let's talk about patient education themselves. At the moment we're using CD-ROMs, pictures, diagrams. There's no reason why AR and VR couldn't be used for patient journeys, patient education, about procedures, about their role, having an immersive environment. That's the first thing. Second thing is around, I guess, therapeutic treatment of lots of illness already. You know, Brandon spoke already about the patient advantages of patient care, using both these technologies and actually being therapeutic, and that's quite important. I think the other thing, of course, from our point of view is teaching and education from our perspective, and also patients might be more equipped, for example, with their own healthcare record systems, allocating them, seeing them in real time. So I guess a lot of things will interface in the AR and VR platform, and we're just at the beginning of that curve.
So hello everybody, thanks very much for the opportunity to speak with you all today, and thanks to VRARA and the Digital Health Committee for the invitation to present at this event. As Chris mentioned, my name's David Traynor and I'm the founder and principal of a software company based in Northern Ireland, UK, called Symposium. We're focused on creating software platforms and apps that deliver very highly individualized or personalized augmented and virtual reality experiences for education, training and guidance purposes. Medical and healthcare is one of the key market verticals that we focus on. So the subject of the talk today is personalized VR and AR for autistic people. We're looking at this area primarily because autism as a spectrum disorder means that people on the autistic spectrum obviously present those characteristics to vastly different degrees and combinations. So we thought this would be an interesting area to try to apply a hyper-personalized approach to authoring VR and AR content in a way that perhaps couldn't be realized by the traditional manual-based pre-authoring of content. So that's really the background to why we focused in on this area. So unlike my colleagues who spoke previously, I'm coming predominantly from a technical background. So our medical expertise is brought in through partnership with a vast array of clinical partners who we work with in terms of making sure what we produce is fit for purpose in the medical and healthcare sector. So next slide, please, Chris. So just to maybe start by setting the scene a little bit on autism, the tool here that's shown on the slide is very much the classical clinical or diagnostic tool known as the triad of impairments. So really in terms of formal diagnosis of autism, these three kind of major characteristics or aspects would be looked at and diagnosis made on people exhibiting these characteristics to a certain level or certain combination. So the three aspects are social communication, which also covers speech and language, just literal language, difficulty in understanding jokes, sarcasm, figures of speech, and so on. Second aspect is social interaction, which is difficulty with relationships, friendships, teamwork, and so on. The third aspect is social imagination, which kind of relates to a rigidity of thought, a resistance to accept change or a difficulty in dealing with change. And also another aspect of that is a difficulty around empathy or the ability to project yourself into another person's shoes and empathize with their situation. So these three aspects come together with the autism spectrum shown in the middle here. So typically for a diagnostic purpose, a person must exhibit a certain degree of the majority of these characteristics. Next slide, please. So falling out from those various characteristics, autistic people typically exhibit some subset of these issues. High social anxiety, reluctance to engage in social interaction, rituals and routines which can involve speech or language-based routine language. It can be physical, hand flapping. They can be mental, or just really any kind of routine activity that creates a sense of comfort in the person. Sensory issues are also a primary concern for an autistic person, and very often there is a under or overstimulated sensory system, which means some people are oversensitive, maybe to visual or oral information. Others are undersensitive. So you can imagine then, from a virtual augmented reality content point of view, that would make a huge difference in terms of how an autistic person perceives and either enjoys or doesn't enjoy a particular AR or VR experience. Quite a high proportion of autistic people actually have difficulty around fine motor skills. And that's getting slightly better, at least as far as my part of the world in the UK is, in terms of intervention from occupational therapists. So on tends to be happening earlier in life now. But it's still fair to say that a lot of young autistic adults will still have difficulty with fine motor skills. Skills generalization is another issue to be aware of. So autistic people typically will exhibit very high degrees of ability in a very narrow range of skills, but will often be unable to generalize those skills even slightly to similar tasks. And then finally, as I mentioned, a lack of empathy, or a difficulty with empathy. And actually that extends both ways, in as much as the autistic person, through the nature of their condition, has difficulty in empathizing with others. But equally, majority, I would say, of neurotypical people also have difficulty in trying to understand the perceptions and motivations of autistic people, or understand why they react in certain ways to certain situations. So that lack of empathy is almost goes two directions. Next slide, please. So linking this through into why we might want to apply augmented and virtual reality for use by people on the autistic spectrum. These are just some of the, some of the application areas that we've been looking at. So obviously, particularly in VR, being able to simulate various social interactions in a safe environment can be useful to help develop an autistic person's social skills. It can also be used as part of a gradual desensitization program. This is typically used for someone who has particular difficulties around sensory processing. So particularly if it's an overstimulated sensory system, then we can create carefully crafted immersive content to try and slowly desensitize people to those various sensory inputs. Motor skills development, so a lot of the control motion and so on that's required to interact with and control immersive games and applications can be carefully reused as a means of developing maybe underdeveloped motor skills. Knowledge retention, so we find it a great training tool generally, or educational tool, to give people on the autistic spectrum new knowledge, and also being able to use the technology to create subtle variations of typical scenarios as part of a means of overcoming this skills generalization problem. So getting users proficient at a certain set of tasks, and then slowly introducing subtle variations and personalized variations in the AR or VR scenarios, so as to try and extend those skills out over a slightly wider area. And the final area then is actually trying to simulate the effects of autism as a means of simulating that for neurotypical people. So an example, in the UK recently, the National Autistic Society released a very interesting 360 video which depicted the sensory overload experienced by a young autistic boy traveling with his parents through a very busy shopping mall, and the visual and audio effects were exaggerated in certain ways to try and get across to neurotypical people about how that environment feels to someone with autism. Next slide, please. So those are some of the benefits. On the flip side, these are some of the challenges that we've encountered in trying to build in trying to build support software for autistic people. First, as I mentioned, it is a true spectrum disorder in as much as the characteristics presented do vary, from individual to individual. So it's personalization down to the individual level that's really required to deliver an experience that is tuned to the input processing, the sensory processing, the preferred style of each autistic person. I mentioned sensory issues, so obviously that has a huge effect on the content design, both for augmented and particularly for virtual reality in terms of colors, sounds. We found a certain proportion of autistic people who maybe have tactile-based sensory issues may not like the sensation of wearing, for example, a VR headset, so you might have to come up with alternative hardware that maybe reduces the immersive aspect, but from a tactile and sensory perspective is more suited for that individual. And one technique we've been using quite a lot is the concept of diminished or mediated reality. So for those who aren't familiar, this is essentially augmented reality in reverse, where instead of using digital media to add objects or detail to a real-world scene, we're actually using digital media, a computer-generated content to soften or mute or even obscure real-world objects that might cause sensory overload in an autistic person. So really it's trying to dial down, if you like, the level of sensory input that person is getting. It's not a widely used technique, but it's proving to be quite a useful approach in this particular area. And it's almost like the digital equivalent of the kind of enclosed workstation style desks and so on that many autistic people work in to try and avoid being overstimulated visually by objects in the environment. The final challenge that we've identified is getting back to this issue with fine motor skills. And it's really affected the way we've gone about user interface design for many of these apps. So quite a large proportion of autistic people will have difficulty doing very fine and precise movements on handheld VR controllers, for example. So I've shown the example of the Gear VR controller in this slide. So we've actually started to go down the road of looking at, I guess, multimodal interfaces where a personalized combination of touch, speech, gesture, commands, and so on can be used to drive the system in different ways. And we find that useful, and we find that individuals will gravitate towards the particular input modality that best suits their preferences and sensory issues and so on. Next slide, please. So I want to talk now a little bit about a very, very new project for us, and it's actually in the vocational training area, but looking at autistic people as the trainee cohort. So we're working with a local training organization called Orchardville, who, amongst other things, train young autistic adults in catering industry and in particular how to work in a coffee shop. So it's barista training. And we're looking at this primarily to address some of the quite severe underemployment levels that's seen in young autistic adults. So only in the UK, about 16% of eligible working age autistic adults actually have a full-time job. So it's quite a serious problem, and one we're interested to see how immersive-based training can help deal with this. So it's developed in partnership with a local training organisation. So we're calling we're calling this particular piece of software Appuccino because it's obviously related to working in a coffee shop and becoming a barista. And it's quite interesting in as much as we're using this as a vehicle to try out some of these technical ideas around creating individual or bespoke or personalized immersive experiences, but in a real-time automated way, rather than trying to estimate all the different combinations at the content authoring stage, and hoping that that covers all the user base. Next slide, please. Okay. I think we jumped to there. Yeah, that's it. Yeah. So essentially, this particular system we're developing, it's split into two aspects. So we're using augmented reality as part of the of supporting really the on-the-job training aspect of this, and really that's using AR overlays on top of real-world industrial coffee machines, electronic point-of-sale tills, and so on. So it's very much geared around supporting the training that the autistic person needs when they're actually at the dedicated training center or working in a coffee shop. And actually the training organization we're partnered with also has a number of commercial coffee shop outlets, so the trainees do actually get a chance to work there and deal with members of the public and so on. The other half of the system is a virtual reality-based coffee shop simulation, and really this is around trying to get the autistic person to become gradually more accustomed to the sensory input generated from a busy catering establishment, the social interactions and the anxiety that can generate in terms of dealing with customers. And also these same experiences can be used by neurotypical employers and co-workers to gain a better understanding of what these environments are actually perceived like by an autistic person. So the hope is that will generate a higher degree of empathy in that direction. And all these capabilities are driven by an automated personalization software that we've developed. So effectively we have a very large repository of fundamental media items in a database, but we actually use machine learning and a form of artificial intelligence to actually compose those in multiple ways for each individual. And we capture analytics on how each person uses the system to decide what that combination should be for each person. And obviously the system adapts and learns as each person uses the system more and more. So it's a self-learning type of application. So we believe that this has great possibilities in trying to get the very high degree of personalization that's needed to address the autistic population, but without a huge content development, a manual content development burden on ourselves as developers. Next slide, please. So this is a brand new project. We're only a couple of months in. The training center that we're working with has a fresh cohort of 15 trainees who are really going to act as our co-design team. So we're working very much in an agile, iterative technology development way. We're currently filming some 360 video in the coffee shop that Audrey will run. We've got some very good initial feedback from the trainees on some of our kind of initial proof of concept around user interface and control, and really just the general concept of the Appuccino app. So we're estimating it's probably going to be a 6-month development cycle. So the current cohort of trainees will really be acting as the co-design element, with the hope that this will be in place for future cohorts at the start of the next academic year to take benefit of the completed system. Next slide. So happy to take any questions on that. My contact details can be seen there. I believe the slides are being shared, so I'll try and get through as many of the questions as I can. If not, please feel free to contact me by any of the means shown here. And thanks for your time and the opportunity to talk with you.
So first question for you, David.
Okay.
What devices are you using to measure EEG?
Okay, so currently, at least for this project, we're not measuring EEG directly. I'm imagining the question is asking where we're getting the data to drive this this personalization aspect. Assuming that's the case, really we're getting that from looking at the interactions and the reactions to the content we present, and inferring from that things like whether the person's engaged with that content, whether a certain training outcome's being met, whether a person's showing signs of confusion or distress, and then using that data to help drive what the next set of content should be. Now, separately to this project, we have done some very early studies with some of the, I call them consumer-grade EEGs. So these would be more consumer or lifestyle EEG products rather than full medical-grade EEGs. And we've been using that predominantly to try to measure levels of engagement from individuals in terms of looking at brainwave patterns to infer the degree to which a person is concentrating on or engaged with a certain piece of media within an augmented or virtual reality experience. But that's on a separate project, so it's not actually combined in with this one.
Great. Next question. Why did you choose to serve the autism market and not another disease state market?
Okay. Well, there's a few kind of reasons behind that. One is obviously the high degree of individual variation within the autistic community. We thought was a good match and an interesting match with what we were thinking on the technical side with using machine learning and AI to automatically create bespoke experiences. Because we thought that was an area where such a high degree of personalization was needed to get good results for each person. That the autistic community would be a good area to address with this. The other is that from other projects and other products, we in Centennial had worked quite closely with a number of autism support organizations and a number of autism groups. So it was an area and a community we were quite familiar with and comfortable with in terms of having worked there before. So I think between that historical partnerships we had and the good match we saw between that user base and some of the technical ideas we had, I think the combination of that led us down the road that we're going.
Great. Next question. How do you measure the success of your autism research given it is tailored at such an individual level?
Okay, so and that's somewhat application dependent, but if I talk in the context of this particular project, so this is developmental and training application. So actually the measures of success are partly based on training and learning outcomes. So the rate at which people acquire the skills, can generalize or diversify the skills, and feel comfortable and confident about working in that environment despite certain social and sensory challenges. I mean, those are the ultimate measures of success. And we use the outcomes of the analytics process that we carry out to infer for each individual how they're progressing along each of those different measures. Now, we've used this type of technology for a number of other educational scenarios, some medical related, some not. And the success measures tend to be somewhat different there. They might be more educational training based and less in terms of coping or self-managing an inherent medical condition, but essentially the general approach is the same.
Great. Well, thank you. If you have time, David, stay around for our ending Q&A. With that, we will go to our next speaker, Amy. All yours.
Hi, everyone. This is Amy Peck. I am the founder of Endeavor VR. I work with primarily Fortune 1000 companies on leveraging the technology, and I do work with some startups as well on kind of overarching go-to-market strategy and roadmap and development resources, platform partners, so really sort of helping bridge the gap between the resources and platform partners and the needs of enterprise. I believe I'm the only non-physician in the group today, and so today I'm going to really talk more about the business of XR in healthcare. So whether you're a medical institution or a practitioner, looking at this technology and looking at ways to leverage the technology in your own practice, or if you're a physician who looking to, like many that you've heard today, who are looking to develop a particular product. I'll speak to a little bit about what the opportunities are and what the approach might look like. So the opportunity, let's look at the market, and this is a slide from about a year ago, but the projections, are still pretty close if you can look at the more current projections. And healthcare in and of itself is looking to be somewhere in the neighborhood of a $5 billion industry by 2025. When you add wellness into that, that will kind of dig into a little bit of that consumer market. At about 18 or 19 billion. So that number could even, as much as double over the next 7 or 8 years. So it is a big opportunity. So for what that means, for those looking to leverage the technology is that it's likely that there's going to be some, incredible solutions. And, I think what you've heard here today are all, each one of these solutions that, my fellow VRARA committee members are putting forward. This is a substantial and sustainable market. So you've heard a number of solutions today already, but these are the areas where I see the most traction and at the same time the most opportunity. And even though there are a number of solutions for sort of each of these categories already out there, as the technology evolves and as you just heard with David Trainer, bringing in some of these other, adjunct technologies, machine learning, AI, computer vision, leveraging these technologies and layering them on these, all of these solutions can evolve, and there is plenty of room, in each of these categories to move forward. But I'll just speak briefly on some of the opportunity. And we heard a little bit about, utilizing XR for surgery, visualizing a difficult procedure, planning and practicing a procedure, but then also being able to access that plan, actually in OR. Training is another huge opportunity. I do a lot of sim and training with my clients, both in healthcare and industrial. But so, being able to, bring traditional medical school curriculum into VR, so students are actually, kind of the classic learn by doing. This gives them a leg up before they're actually in that kind of practical situation, and the opportunities, of course, for one-on-one or one-on-one training or specialized procedures. And what's really phenomenal is then having an archive of, we talked a little bit about the live surgery. Having an archive of these procedures where students can actually, not just watch 2D videos of these procedures, but actually stand next to surgeons as they perform it, gives a completely different level of education. Pain management is another great area. There's actually been a number of solutions out there in the market for several years, so there's some very good data so far, and a couple of different approaches. When you look at, for example, cancer patients or burn victims who are in incredible pain, giving them even just views of soothing environments, and then maybe adding kind of an engaging game component on top of that really helps to redirect attention. And there's great data to support the efficacy of these types of solutions. I'm seeing a lot of research. The virtual environment is in and of itself a sterile environment. So, being able to do cellular research, Big Pharma is doing a lot of, work with VR and being able to iterate. And it's incredibly valuable to be able to manipulate cellular data, particularly cellular data that might be very rare or delicate, to use those scans in a virtual environment. incredibly valuable and time-saving and money-saving. Rehab and physical therapy, I've worked actually with a couple of companies doing some therapies for stroke victims, which are often, the exercises are pretty rote, dull activities. And so being able to kind of gamify those, that really increases the likelihood that, the patients are actually going to complete those tasks. And it serves to retrain the brain sort of both physically and perceptually. So we're seeing some really great solutions already out there, but there's still a great opportunity to build others. Wellness is interesting because, again, that touches the consumer market. So some of the more kind of traditional clinical applications, more lightweight versions can be deployed for consumers, and it's also actually a very, very good way to get feedback on sort of UI, UX, and sort of general practices while you're building your application, and especially if you're planning to go into a more medical version where it's you have to go through some kind of a clinical trial. Having a consumer version early can take out some of the pain of going through that process, because you will already have a lot of user feedback, even if it's not in a clinical environment. And then behavioral health, I actually was just at, in fact, I saw Brandon Burkhead at the Stanford Medical Symposium on behavioral health. There were a number of clinicians and therapists and physicians who've been working on various clinical trials, and there's been really incredible data so far to, kind of speaks to the efficacy and really across, a number of issues: phobias, anxiety, PTSD, addiction, depression, social disorders, and our last talk about autism. These are really life-changing solutions, and because there's so much in this kind of umbrella of behavioral health, I think this is another opportunity to really kind of expand on some of these solutions. And I left empathy and collaboration last because I think that these are two areas that have not just, sort of clinical applications, but really, really broad-reaching implications for patient care. So with empathy, being able to kind of train practitioners on correct procedures, but the flip side of that is helping them to understand, firsthand what it's like to have a patient's particular ailment, and not only are they then able to react in sort of a procedurally correct manner, but it gives them that kind of deeper understanding and empathy for everyone. If all of us take a step forward, I mean, it's sort of a life-changing concept that we're all able to just understand each other a little bit better. And so when it comes to that linear procedure, we're just able to execute, in a much better but more meaningful way. And collaboration, I just actually gave a talk in Munich about just the notion of global collaboration, and we have the tools now. We have the tools, the Unity and Unreal Engine, which are the game engines that most of these experiences are built on, have, what's called a multiplayer mode, and so multiple people can be in the same environment looking and manipulating the same objects. And I think in terms of, from a medical standpoint, for, physicians who are incredibly busy people, to be able to collaborate together, but those even from remote locations. But if we take that a step further, perhaps there's this opportunity for physicians to engage other physicians from entirely different disciplines. And, I'd love to sort of see the medical community and get feedback from the medical community on, what that value would be to be able to look at many different disciplines for a particular procedure or ailment that is on a particular surgeon's plate, and really looking at many, many different outcomes and procedures and possibilities and what that means to patient care in the future. So this is a much more kind of pragmatic look at building a product. And if you are looking to buy a product or license a product, these are some of the things that are just the global benefits of, XR, which is the umbrella that we're, using for all, AR, MR, and VR. But the high engagement factor really kind of boils down to high retention. So if a student or a patient is engaged, they're much more likely to retain, or they're much more likely to complete a particular task. And you're able to then, again, going back to David's talk, they're really using the data piece. You're able to really record every single interaction, so that looking at how those interactions are playing out and the level of engagement, and then using that to both iterate but also to sort of measure the ROI or the efficacy of a particular application. And it's sort of infinitely customizable. So you can, build any kind of environment. You can use any kind of asset. You can do really virtually any kind of scenario. And again, that consistency piece where if it's lessons or if it's procedures, that from therapist to therapist or patient to patient, they're getting kind of that consistency throughout. And information overlays is another kind of interesting piece about it, and I think we've touched on it a little bit here today, and it's both sort of an AR and VR construct, but being able to layer relevant information or historical data onto whether it's a 3D scan or whatever the object is, also has and so not to get granular, but this will just give you an idea of the things to think about when you are looking at a solution, if you're looking to build a solution. And again, what is the problem? Who is the patient? What technology? Is it AR, VR? Is it mobile? Is it web-based? And compliance issues, which are a big thing. And of course, anything with touching patient outcome will have to go through, either a clinical trial process or being approved by the FDA. And then moving forward from that, what is the minimum viable product? What is the go-to-market strategy? Pricing, platform. These are all elements that we need to consider. And if it's just an application, and really it's just on this bottom part of the slide, really just have to think about that front end and the interaction piece. But if you're looking at sort of a larger solution, you need to look at sort of that front end, that middleware piece, and the back end data, and then how that layers into any existing systems. And I'm happy to answer questions either online now or offline with I'll leave my information here. So thank you so much.
Thank you, Chris. Hello, everyone. I want to thank VRARA Association for this great event and all the presentations. We learned a lot today. My presentation today is on challenges and opportunities that VR is providing for special needs, specifically with autism. Next slide, please. If you go through, very fast, go through the literature on virtual reality and special needs, it's amazing that it's going back to mid-70s. Just putting together these two keywords takes you to publications from mid-70s that they've been using some sort of virtual reality, obviously, with a different definition from what we have today. And they've been using it for, especially in autism or in other disabilities, for improving social skills. They've been using it for treatments, rehabilitations, and social cognition. A wide variety of special needs were covered, like cerebral palsy or autism spectrum, Asperger's syndrome, intellectual disabilities, and so many other disabilities. And interestingly, one issue which stays with us over the last few decades is motion sickness. It's interesting that how motion sickness is kind of reported in every study since mid-70s to today, which hopefully with the new technologies and the better design patterns, we can reduce that, especially when it comes to kids like autistic kids with huge sensory issues. Next slide, please. But important question, which I think it's not completely showing in this slide here, is that is virtual reality an opportunity? Okay, like every other, maybe a lot of you guys don't remember these technologies in this image, or some of you remember it from old days. Each of these technologies, they brought something into our lives. They had opportunities. They became very important and vital in our lives because of the ways that we used it. And you can name a lot of technologies that were just forgotten because we didn't have a good use to it. And that's exactly what's happening to virtual reality. It depends how we use it, how we facilitate it. It can be an opportunity, or it can be just another hype that goes away very fast. Next slide, please. But why virtual reality is important? David touched on a lot of these issues with autistic kids, and this slide and the next one are not only applicable to autism, but I think in general in health it's true. One very important thing that we gathered from talking to different people was the wow factor that virtual reality creates. Some people think that, oh, this can be just something on the side and it's not important, but it's actually important. Doesn't matter if it's in education or in clinical use or treatments. You need your patients, you need your kids to be interested in what you're giving to them, and virtual reality can provide that factor. Another factor which is very important is the opportunity to explore what's not explorable at the moment, both on for kids on the spectrum and kids who are not on the spectrum. It's the same thing. Imagine you want to take your kids to a museum, 10 or 20 autistic kids. Usually museums are quite full of people, a lot of noise, a lot of sensory issues for autistic kids. But now imagine you can have the same journey personalized only for the student without any issues with sensory problems. And you can just give them this opportunity to explore different places from where they are. Another important factor is it helps us to increase availability and accessibility. You can't take, for example, 10 autistic students to United States or to France or to Asia for a tour, but you can easily use virtual reality to help them to go on journeys like this. And more important, all these journeys, all these experiences are very safe, and you can control it, unlike classrooms or labs. As David mentioned before, again, they can be personalized greatly, and they can be adapted to each kid, which is very important when it comes to autism, as almost none of the kids are similar. And they provide you with a great potential for engagement, which is very important. Getting these kids to engage with the content, with what you are giving them, is one of the most important issues that currently we have. Next slide, please. So going to our journey with autistic individuals, we had a lot of chats with experts from different companies, different institutes, different research centers, and this list is like a generalized ideas of what are the current challenges that we are facing in autism. The problem is that individual tolerance towards virtual reality is very different, and we kind of need to see how it relates to measurable factors like sensory profiles and things like this. Virtual reality can be used and facilitated for distraction and pain management in ASD kids. A lot of sensory challenges and generalizability for learning skills, especially in vocational training, which is kind of a lost opportunity currently for kids on the spectrum. Mentoring programs, unfortunately, we don't have much of them. That VR Advised Realities, we are working on mentoring programs for high-functioning computer science students who are on the spectrum to develop for autistic kids. Motor development, executive functions, and symptoms are another challenges that need to be addressed. Technology adaptations, because currently the way that the technology is kind of a challenge for students, especially those who can not tolerate having a goggle, like half a kilo goggle on their head. Investigation for suitable levels of immersion is very important. We don't have any idea how these kids react to different levels of immersions. A very, very important issue is the possibility for addiction to virtual reality. We know that there are publications and there are studies on the possibilities for addiction in games. Virtual reality adds a lot of immersion to games and to contents. And another problem is the UI design. We need a number of communication channels to kind of personalize these experiences. Can we go to the next, please? But what is needed to be done, it's just a very small summary. We need, like any other field of health, we need a standardized guidelines in autism as well. It's very important for all the researchers, all the users, patients who want to go out and use virtual reality for autism. Accessibility of information is very important. Unfortunately, all the research that we went through are disjointed. They don't communicate clearly, and a lot of these information are not on the market, on the publications, because they are done in for-profit companies and are not available as academic publications. We need more support, especially for less developed countries. We have a lot of issues in a lot of countries when it comes to autism, even for very simple support. We need a more holistic approach towards the special needs, and that includes creating solutions not only for the kids, but for families, for educators, and in general for public, for other kids who sit in the same classroom and they don't understand. And it's unfortunately and sadly amazing how we are not educated for dealing with autism. And the last is that we need collaboration, especially when it comes to health and autism. We need collaboration. This is not a competition. Unfortunately, most people look at it as a competition, but we need collaboration to go forward. Thank you, Chris. Can we go to the
Thank you. Thank you. So we're running out of time, but we'll take some remaining questions, and any of our presenters can feel free to pitch in. What is your methodology for training social nuance? How does VR train soft skills of the job, such as being personable with customers?
It's like a David or Ali type thing. I don't know. Did either one of you did research on that?
Yeah, like really quick comments. I mean, from our perspective, the approach to that's really around trying to measure whether certain social cues are picked up successfully by the user or not, in terms of the presentation of the response back to the virtual person that they're conversing with, and so on. So really, it's around things like that we would use as a measure of success of understanding and responding to social nuance.
Question is, can you recommend any available apps today in the app stores for VR that can be used with simple headsets like Google Cardboard?
Cardboard. I reviewed maybe 100 of the apps on Google Cardboard for my research study with cold pressor tests, and I'll definitely say there's not a lot. There's the Bohemian Rhapsody that we kind of looked at maybe for the study, but we ended up having to actually make our own combination. So on the Google Cardboard, you kind of get what you get with the cost of it. You kind of have to move up to the other ones that are about $60. Unless other people find other ones that you like on Google Cardboard.